Okay. All right. Well, if you have ever been sitting in a math class and you've wondered, when am I going to use this stuff in my life? I don't actually know the answer to that question because I don't know what you're going to be doing in your life. But what we're going to do is we're going to be using some of the math we learned back closer to the beginning of the semester to actually do some like real life data analysis that was done. We're going to use a data set somebody used about 30 years ago. And we're going to sort of go through this person's data and draw our own conclusions from this data. Okay, so this is very much a real life thing. The paper that we're going to be going over has been cited over 100 times. So people are in whatever sense applying this to do things in the real world. Okay, and it's going to be good practice for you guys to kind of use mathematical skills that we've learned in this class to analyze data. So this is the project. This video might be kind of long, so that's what this video that's referred to in the project here is the video that I'm currently making. So if you've got here, you're doing the right thing. So I'm going to basically describe what I want you to do. What I've said here, I'm going to describe what I want you to do, and even kind of show you how to do parts of it. So this could possibly be, I don't know, a long video. I don't know how long it'll be. If I was Tom Scott, I could know it was going to be 20 minutes and 35 seconds. I could tell you that right now, 20 minutes and 35 seconds. Yeah, and then the video would end at exactly 20 minutes and 35 seconds. But I'm not Tom Scott. I'm me. All right. All right, so what I'm giving you. So let me kind of go through what I'm giving you. This is project 1. Your canvas is going to look a little bit different than mine. I could go to student view here, but I haven't published this module, so you wouldn't be able to see it. So you're going to see project 1, and you're going to have several pieces of information or several links here. One is going to be a link to this paper by Robert Druszinski, who I believe, what we can see right here, was in these departments. This paper was in the Journal of Theoretical Biology in 1993. And this is the time allometry of mammalian chewing movements, chewing frequency scales with body mass in mammals. Okay, and there's other animals as well that he's looking at here. Okay, so, sorry, I just checked that they are all mammals that he's looking at here. We'll talk about the difference in a second, or the different groups of animals that he's looking at in just a moment. Okay, so what he's done here is in this table here, he has compiled these data from a bunch of different sources. He's listed the source here. And then this column, so this is the name of the species here. This right here is the mass in grams of the animal being studied. So this, like a space means a comma. So like 13500 means 1,350 grams. So here is the mass in grams. And this right here, T chew, measured in milliseconds, T chew, this is the period of the chewing. So in other words, it takes this animal, I forget what it is, I don't know, I looked it up, I forget what it is now though. It takes this animal 250 milliseconds to do one chew. So like open your mouth and closing that, like he's counting that as one chew. Okay, so that is the period. It takes 7 milliseconds for this animal that has a mass of 7 grams to complete one chewing cycle. This is measured in milliseconds. Okay, and so what we want to do, what he wants to do in this paper is he wants to convert the period of chewing to the frequency of chewing, but measured in seconds. Okay, so the relationship between period and frequency is they're just inverses of each other. So if I wanted to know the frequency in milliseconds, I would just divide this by, I just do 1 over 250. So there's 1/250th of a chew per millisecond. Okay, now that doesn't quite make sense. It makes more sense to measure the frequency in seconds, like how many chew cycles per second. So first we have to divide all of these data by 1,000. That's going to give us the chew period in seconds. So if I do 250 divided by 250, there's 1,000 milliseconds in a second. If I do 250 divided by 1,000, I'm going to get 1/4. So in other words, he does, this animal does 1 chew every 1/4 of a second. So that means he does 4 chews per second. So we have to get frequency, which will be called f sub chew, we have to divide to get frequency in seconds, we have to divide all of these by 1,000 and then do 1 over all of that. That'll give us frequency. And then so in this column, we would have the grams of the animal's mass in grams, and then in the other column we would have the frequency of the chew. Okay, so another thing, and I'm going to show you a spreadsheet, which is what I'm doing now. In the project folder, if you go back to the project folder, there's a link to a spreadsheet. That's what this link is here. This is the link to the spreadsheet here. So this I've already inputted the data for you. You'll get a copy of this. You can't edit this directly. You'll have to make a copy into your own Google Drive and copy it there. I think you can just make a copy like that. Make a copy, put it in your own Google Drive. Okay, and so I've put all of the data here. We've got the mass in grams here going up to here, and then we have the period chew. So what you're going to do over here is you need to write the frequency for the chew. Okay, so how do we do that? Well, again, it's going to be equal to this divided by 1,000, and then we're going to divide that you're going to do 1 over that. So it really just works out to being 1,000 divided by this. So the way that we do that, so I'm just going to copy and paste these data here. So you're going to have to do this for yourself. I'm showing you how to do some of this stuff. I'm going to copy and paste that there. And then this, for a formula, we're going to write equals. And I want it to be this 1,000 divided by this. That's going to give me the period. So this is going to be 1,000 divided by B3. And so, okay, and so now it says, do you want to autofill all of those? If it does that, you can select yes. If not, you can select this and pull this down. Okay, if you know how to do Excel or spreadsheets, you've seen this before. Okay, so now what this says is that this animal, I deleted the name of it because I didn't feel like typing it all in, and it doesn't really have anything to do with what we're doing here, but it's kind of interesting to refer back to the actual animals. At any rate, what this is saying is that this animal chews, on average, 4 times per second. This animal chews 5.46 times per second, and this animal chews a little less than 1 per second, about 1 time per second. I think this is like the African elephant. Okay, so now we have these data here, okay, and we're going to do a couple of things. We want to plot it. So here we're going to make a scatter plot with these data. And I'm going to show you how to do that with another data set because I don't want to show you how to do it with this data set because I want you to think some for yourself. Then over here we're going to do a semi-log plot. So the mass will be the mass and the output, that is the frequency of the chew, we'll do a log plot there. So this will be a semi-log plot. And then over here we're going to do a double log plot. And basically for each one of these, or not basically, exactly what you're going to do for each one of these, you're going to make a scatter plot. And you're going to try to determine which one of those scatter plots looks the most linear. Which one of those scatter plots looks the most like a line. And you're going to use that as the data that you're going to analyze. And then you're going to do linear regression on that data. And the linear regression is going to tell you approximately, like remember if it's let's say we pick this one as the chart that looks the most linear. We do linear regression on these data here, where here we're going to have log of mass, here we're going to have log of the frequency of chew. We're going to do linear regression, and what this does is it tells you what the slope and what the y-intercept is, or the vertical axis intercept is, for the line of best fit. Okay. And then what that tells us is that if we look at the double log plot of these data here, is going to tell us what the equation for the line is, and then from that we can convert from that back to the original thing by raising things to the power of 10. Okay, so that's the next thing that we're going to do. So I understand that might be a lot for some of you if you haven't done this stuff before. So I took some data, another data set from the same paper. It's on page 436. This is the body mass of an animal, and this is the total physiological cross-sectional area of the jaw abductor muscular. That's what this is right here. measured in millimeters squared. Okay, so I'm going to do this is just a normal plot here. I'm going to do a scatter plot. I'm going to do a scatter plot here. And the way I do a scatter plot, I'm going to go Insert, Chart. It's going to give me some options. This isn't exactly what I want, though it's not so bad. I want to do a scatter plot, so I'm going to come over here. It says Line Chart. I'm going to pick Scatter, and it already labels everything like I need it to. So make sure the labels are there. So this is the scatter plot without doing any without doing any logs or anything like that. Now this honestly looks like it could be kind of linear, but one thing that we want to look at here is the mass varies by several orders of magnitude. Here we're at 0.03 and here we're at 2.78. So the mass is varying by several orders of magnitude. So this leads us to think perhaps we should be thinking about doing a log plot here. And this is the input variable. This is the x plot variable. And the type of log plots we've looked at so far there's been two kinds, either where we do the dependent variable, that is the vertical axis is log, and keep the horizontal axis linear, however it is, or we do both logs. So this suggests maybe we should be doing a log plot for the horizontal axis because of the varying in orders of magnitude. And we also kind of see something here as well that's varying in orders of magnitude. We have some here, and some there. So that suggests that we should be doing log on the independent variable. That is on the, I don't know why I did like this. We should be doing log on the horizontal axis variable. And the only logs we've looked at so far, the only log plots we've looked at so far are the ones where if we do a log on the horizontal axis, we also do log on the vertical axis. Okay, so that's what we have over here. This would be a log plot. Okay, so how do I get different log values here? Now, the way that you should not do it, you shouldn't get a calculator and put log of this and log of that and log of that and just copy it there. You should use the Excel formulas, which is going to be equals log. So we have different logarithms, and I'm going to do log 10 of, and I'm going to put the cell, which in this case is A2. And I'm going to press enter. And now I want all of these, so I'm going to take this and drag it down, and it just typically does pretty well about what you want it to do. But if I look at this cell, the formula is log 10 of A3, which is exactly what I want it to be. And I'm going to do something similar over here. This is going to be log 10 of B2. I'm going to press enter, and I have this autofill suggestion. You can use that if you want. I'm not going to because I want to show you again. I'm going to take this little blue dot, I put this over it, it turns into a plus, and I drag it down here. Okay, so now what I want to do is I want to do a scatter plot for this. Now, in the project, there's going to be a semi-log plot that you're also going to do this with. Okay, so I'm going to do a chart here. Again, it's insert, chart. I want a scatter chart. It already knows what I want. It already has this labeled well. It already has the things labeled well. And if you look at this, this looks a little more linear simply because over here we have these three groups of data, right? But here, because we're on the log scale, the data on the horizontal axis is spread out a little more evenly. So I'm going to say that of these two, this one, the double log plot, looks a little more linear than this one, simply because the data is spread out a little more on the horizontal axis here. Okay, you could actually do either one for this. This, I think, either one works, but I'm gonna say we're gonna use this here. Okay, so now these give data, like these two columns here give data that are linear. In other words, the input variable is the mass, and the output variable is, the input variable is the log of the mass, the output variable is the log of the cross-sectional area of the jaw abductor musculature. Okay, and so there's a linear relationship between these two. And what I want to do is I want to find the line that best represents, so they're not, these data obviously don't lie exactly on a line, but I want to find the line that kind of best fits these data. And to do that, we're going to use the Google Sheets, same thing as Excel, I believe. I think it's the same function. It's linear regression. And so what I'm going to do, I'm going to pick this cell here, and I'm going to say equals lin est, so that's linear estimation, lin est, best fit linear trend via least squares. The first entry, the first thing I'm going to write is going to be the column of data corresponding to the output. So the output variable is going to be the log of the PCA, the log of the jaw musculature, or whatever. So I'm going to put G2 colon G8. That's going to give me that set of data there. Then I'm going to do comma this column, the input variables, that is the mass. So that's going to be F2 to F8. Okay, so I'm just going to do this. I'm going to press enter. This right here is the slope, and this is the intercept. Okay, so in other words, what this is saying is that these data right here, the line of best fit, is approximately going to be equal to y is equal to 0.7919477952 x plus 0.952415985. Okay, like approximately these data satisfy this linear relationship here. Okay, but remember y is really log of mass. So I'm going to write this as log of mass. You don't have to write this stuff here. I'm just writing it here to kind of explain what's going on because I don't have anything to write on. And then, or sorry, no, this isn't log of mass. This is log of PCA. And then x here is log of the log of mass. Okay, so I don't care about the relationship between the log of the PCA and the log of mass. I want to know what is the relationship between this PCA thing and m. And so to do that, I'm going to raise both sides to the power of 10. When I raise the left-hand side to the power of 10, I just get PCA. When you raise the right-hand side to the power of 10, you're going to get 10 to the power of this 0.952415985 times m to the power of 0.79194776652 number. Okay, so right now Excel isn't doing it, or the Google Sheets isn't doing anything with this right here. I'm literally writing it here so I can explain to you because I'm not writing down. I'm just imagine like this. I'm just using this as I'm just using Google Sheets for these two shells. I'm just kind of using Google Sheets as a whiteboard because I don't have something to write on. Okay, so you're going to need to know these relationships because when you answer the project questions, which again, if you look in the modules, there's a link to these project questions that you're going to answer. So this says, from the chewing spreadsheet, did you use a semi-log plot or a double log plot? Why did you choose which one? And basically the argument is going to be telling me why one of those gave you something that looked more like a line and why the other one gave you something that didn't look so much like a line. For this right here, once you have performed the regression, use that to write a function that describes the chewing frequency as a function of the animal's mass. In other words, that's the thing that we just did right here, okay? Except instead of PCA, it'll be chewing frequency. So instead of the jaw, whatever, the jaw muscle stuff, it'll be the chewing frequency. And then the next question is, once you have performed the regression, what does this tell you about the relationship between the mass and the frequency of chewing? So does chewing frequency scale linearly with mass? If an animal of mass m naught chews with a frequency of f naught, then according to the model, what would the mass of an animal need to be to chew with a frequency of 2f naught? In other words, how if you want to double the frequency of chewing, what does the mass of the animal? What do you have to do to the mass of the animal? So like here, I would say, well, the mass doesn't double. Like the mass, the PCA, the jaw abductor musculature cross-section area, does not scale linearly with mass. It doesn't really scale how we would, so it doesn't really scale maybe how we would think about it. We might think that it would scale linearly or as a square root, but according to these data, it actually scales as mass to the power of about 0.79. Okay, so that would be one thing that we could say there. Okay, and then so how would we do this doubling thing? Let's say I wanted to know if I have an animal with mass p naught, like what would the mass of an animal need to be? Sorry, if the cross section is p naught, what would I need to happen for if I wanted to find an animal whose muscular cross section in the jaw was about twice this, what would I need to solve? What would m need to be? And you can solve this equation. You can do 2p naught is equal to this. So 2p naught is equal to this, and you can solve this equation for m, and that'll tell you what the thing needs to be. Okay. So if so to be a little more clear, I give this p naught, so p naught would be equal to this with the mass of the animal that was given, that was m naught, and now I want to solve this equation, so it's 2 times all of this. Sorry, again, I can't write on a whiteboard right now. I guess there's one behind me, but you can't see it. So what I'm saying is now this would be, if I have an animal of mass m naught whose chewing frequency is p naught, this right here would roughly be twice. Anyways, okay, I think it makes sense what I'm saying here. If not, let me know. But basically, I just want to use these data if animals satisfied this relationship exactly. If animal chewing satisfied this relationship exactly, I'm saying, like, what would the mass have to do if I wanted the muscular cross section to double, and I would solve this equation for m in terms of m naught is basically what I'm saying here. That'll tell you the ratio by which the mass of the animal would have to change. Okay, sorry, that seems more like I think I explained that more confusingly than I wanted to, so I apologize for that. Okay, then you're going to do all of this over again, but you're going to look at this. This is the chewing for ruminants. So in other words, like, you know, animals, I think that like farm animals. I'm not sure. Farm animals that are also mammals. So probably something with a hoof would probably be what this would be, and that maybe chews grass, because that was another part of the data here. Okay, but if you look at the data on page, 431, I've put this data here. So it categorizes the data into fresh chewing, in other words, chewing the food that it just ingested, and the cud that it chews. I only put the fresh chew there. And then you're going to do the same analysis here, there, and there. So all in all, you're going to have 6 different graphs. You're going to have 3 graphs, 3 scatter plots from here, 3 scatter plots from there. Then you're going to come over to this. You're going to tell me why you choose the log plot, the semi-log plot over the double log plot, or the double log plot over the semi-log plot by answering questions here. And then you answer the rest of the questions. So there's, I think, 6 questions total. When you answer the questions, answer them in this document. There's a link to this document where you can, again, make a copy and edit it. When you answer this, when you do this, write in complete sentences, use correct punctuation, use complete sentences, I don't know if I said that, correct punctuation, capitalization. So here's an example of a wrong response. It would be wrong in the sense that it doesn't satisfy the requirements about standard English usage. Wait, let me come back up here. Where was it? So a wrong answer would be something like double log plot. Double log plot. That was the one that looked like a line, right? If that's so this doesn't give enough information, number one. So that's sort of one of the problems. The other problem is that this is not a complete sentence. You're not using punctuation right. If I wanted to write this grammatically correct, it would be something like, I chose a double log plot because of the double log plot, semi-log plot, and linear plot. The double log plot, or you could write double log plot, or you could write log if you wanted to. The double log plot looked the most linear. This is because, and then you could put why you thought that, or something like that. Okay, but at any rate, this is not complete sentences. This is not good usage of punctuation, all that other stuff. this is, okay? Because that's one of the things that we're doing here. This is a writing core curriculum course, so you have to be able to show that you can write and explain mathematics in a written fashion. Similarly down here. So once you have performed the regression, use this to write the function that describes the chewing frequency. Okay, so here's what I want you to do. I want you to write something like, so I will tell you right now, you should be using the double log plot. Okay, so now you have to tell me why you should be using the double log plot. So they're giving you a huge hint right there. When doing the regression on the double log plot, when doing the regression on the double log plot, the slope was found to be, okay, you're not going to write xxx, you're going to write what it is, and the intercept was found to be, again, you're not going to write y, you're going to write what it is. When doing the regression on the double log plot, the slope was found to be xxx, and the intercept was found to be y. That is the relationship between the log of mass and log of frequency, chewing frequency, is log of, I'll just write here, f is equal to xxx log of mass, I'll just do m for mass, plus y. This means that f is equal to ... and you put whatever it's equal to. You're going to raise both sides of this equation to the power of 10 and put what you have over here. Okay, and you're going to do something similar for both this one and the one that I have up here. Okay, so I'm hoping, and also I just realized something looked weird, but I couldn't quite tell why. Don't write that in bold, write it just in normal font here. And actually, I don't know what's going on. This is right. So that was confusing. So sorry about that. Okay, so this is good. Wrong would be something like, just putting f equals blah 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 blah. That would not be right. Again, you need to explain what you're doing, the mathematics that you're doing. You need to explain using good written communication. So just to clarify, this is what you should be doing. I had it labeled wrong a second ago or a minute ago. I don't know why. I apologize. Okay, so I want to point out one thing. I'm sorry to say, but I think if you look on this page right here, I think he just messes up the data analysis. For one, I do not, so if you want to sort of check your work here, you can tell he's doing a double log plot. That's why I don't mind telling you that's what you should be doing. I think he's doing a double log plot here. You will get this minus 0.128. So by the way, the dot in the middle means point. So this 125.893 is 125.893. Okay, so he makes a couple of mistakes here from what I see. Number one, this should not be log base 10. It should just be 2.100. He also makes some other mistakes. But I just realized the time is 12:28 and today's Thursday, which means I need to be in Heldenfels in about 15 minutes, but I am currently in Blocker. Okay, so that's all of the video that I'm going to make for this. If you have questions, ask in the discussion, ask me in class, ask emails, all those sorts of things. You have some time to do this, so you don't have to rush. If you just sit down and do it, I don't think it should take more than an hour. So make sure you do it. Okay, all right.